So good afternoon and welcome to this backend class. And today we are just going to dive deeper to learn more about some JavaScript concepts like concurrency, how JavaScript handles concurrency. Concurrency means when two things are happening at the same time. JavaScript is known to be single-threaded, means it's only handle one process at a time, unlike Java, another big programming language that are multi-threaded, meaning they can work on, if you have quad core as your processor, like mine is have octa core, like my system have 8 processors. So Java, you can actually multi-thread, say okay, this core, if you have 8 cores, split the processes, the task among all these processes, all these your systems processors. But JavaScript it can only manage one. If you like you have 100 processors, to only select one. So how does JavaScript really manage big tasks and concurrency? There is a trick to it, and that's what we're going to talk about today, at least before we jump into the basics. So the objective of today, we should define and explain concurrency and parallelism, describe how JavaScript handles. Why are we doing all this? On the norms, my task was to just teach you backend and you should just learn server side and you're done. But why this is important, at the end of this course, if you get interviews from like let's say Turing, let's say what Turing will actually score you on these basic things, not for you to build Netflix. You understand? Because these simple things what really matters. When programming language, when they say you know a programming language, especially JavaScript, simple things, how they handle the mechanism which they use to handle some task, right? So we describe how JavaScript handles concurrency, even though it is single-threaded, and identify and explain the component of JavaScript concurrency model, which includes call stack, web APIs, callback queues, that is task queue, and event loops. These are the 4 elements of JavaScript concurrency model, and demonstrate how JavaScript executes asynchronous and synchronous, that is things that happen line by line, that is one after the other, and asynchronous, things that happen parallel, that doesn't have to wait for the other task. Someone can multitask. I'm doing this, I'm doing this. I'm writing this note, I'm teaching, I'm also eating, I'm also communicating with as HR. This multitasking is a synchronous process. But synchronous process means I have to finish this one first before I go to this. That is synchronous. So, introduction, when you run a JavaScript program, it seems like the code can do many things at once, but it doesn't. Like responding to a button click while fetching data from a server. It seems it can do that. However, JavaScript is single-threaded language, which means it can only execute one task at a time on a single, which is its main thread. So how does JavaScript handle multiple activities without freezing the browser? It uses concurrency model based on asynchronous programming, and the event loop is synchronous. Asynchronous. Okay, you call it asynchronous. I think. No, doing multiple things at a time. Synchronous is doing one thing at a time. So JavaScript mimics asynchronous programming. It makes it do more than one task at a time. It is a trick that JavaScript uses to handle those kind of big problems. So that trick is what we want to really dive deeper. You might not totally get to understand it today, but I want you to give you a foundation for you to go and explore further. Because our task, our scope is to understand main stack and then to teach you server side. This class is to cover server side. Event loop mechanism. We are going to be diving into referencing these concepts 1 or 2 times. So it's important we at least talk about what it does. What is single threading means? What does the keyword? These are the keywords we'll be using. Single thread, concurrency, parallelism, call stack, web APIs, callback queues, which is also called task queues, and event loops. These are the keywords. What do they mean? JavaScript single thread means JavaScript runs code in one sequence, one statement at a time in a single main thread, which in a simple definition it runs one task at a time. Understand? But Java is not single threaded, it's multi-threaded. Means it can run 2 tasks at a time. It can run 3 tasks at a time. For multi-threaded languages like Java, C#, you understand? But JavaScript, in contrast, is single-threaded. Means it can run only 1 task at a time. Good. Then concurrency, the ability of JavaScript to manage multiple tasks so that they appear to run simultaneously without blocking each other. Concurrency, the ability of JavaScript to manage multiple tasks so they appear, it is a trick to run simultaneously without blocking each other. They are running concurrently, but so that's what JavaScript concurrency means. So managing multiple tasks efficiently at once. Then it is not running on multiple threads. It's single threaded, using that one thread to multitask. So there's a trick where it uses that one thread to multitask. Thank you. So we talk about parallelism. This is through simultaneous execution of multiple tasks on different CPU cores or threads. Yes. There is parallelism. Why I told you about my system having 8 processors. JavaScript is single-threaded, can only use one processor. There is parallelism, allow it to run on all these old processors to spread it. This is parallelism. So allow your process run in multiple processors. Your system, I think this is quad core. That is 4. Some are dual core. No, it has many systems, especially these modern systems. Quickly. Yeah? Device manager. Let me show you something. Press Windows X and go to your device manager. Windows and X together. X like xylophone. To pop up this thing. Press Windows and X. Window. Wizard. No. I like that kind of questions. Please, if it is, don't. Okay, process. Normally, there are something called processes. While you're on your system, there are processes that are running. So the ability of it to run process, it's contained inside processors. So system with many processors can run multiple processes. Just like brain, somebody who is smarter can do smarter things. Somebody who is dull cannot do smart things. So it's just like a capacity to do process, to carry out activities, system-based activities. Yes, so it's actually a hardware and process that is managed. Welcome, and it's managed. So if you go to your Windows, if you press Windows X and press and just go to device manager, something like this will pop up. If you go to where is it, processor, these are all the things. You go to processors, these are all my processors. This is Intel Core i7 CPU, which is 2.7 gig. Each of these are Core i7 processors. I have like 8 of them in my system, right? And all of them have this 2.7 gigahertz of speed each. So each gigahertz, that is like gigahertz, like the speed. Each 8 of them having 2.7 gigahertz. So this means it's very fast, each of them. But in case I have plenty processes I'm running on my system, it could be spread among these processors, right? JavaScript cannot cannot split your process. A single thread can only work on one. Thank you. You understand? Can only use one processor. So Java, which is multi-threaded, can split your. So this is parallelism, allowing all your processes to be spread across different of your CPU. So the ability to process things. I hope that is at least clear enough, though. Processor is just the thing that makes processes run. The bigger your processor, the bigger processes run. As simple as that. That's it. So quickly, JavaScript is single-threaded, meaning it cannot split all these processes across borders. Quickly, let me check something. Let me see how many people are watching on YouTube. Upcoming celebrity new Koniba Jeff, only one person, Jesus. Kodao. See, only one. You are coming. Very soon. Dear, now. Yeah. So don't worry, let's go. Dear, lunch you. So let's go. So we talked about parallelism. That is true. This is a true simultaneous execution of multiple tasks on different central processing cores or threads. Those things I showed you, these are those CPUs. So spreading your processes across it is parallelism. How am I pronouncing it? Pronounce it very fast. Let me. Eh? You say? Parallelism.
Yes.
It's alright. So running multiple tasks at the same time. So what is callback? This is now we are delving into the JavaScript concept called callback now. This is a structure that keeps track of function calls. When a function is invoked, it's added to the stack. When it is finished, it is removed. Stack is just like an array. An array where you put things. In our own case, we put function calls on the stack. The one that comes first is the first to leave. It's called FIFO, first in, first out. There are different data structures in computer science. We have different data structures. There is one called stack data structure. Stack data structure, we have arrays, we have sets, we have objects like we have seen. There are very large ones. We have lots of them. But there is this one called stack. Stack deals with this process called FIFO, first in, first out. You are stacking a lot of things together. The first that, LIFO, last in, first out. This thing is the first in, first out. The one that is FIFO is first in, first out. But that one is list. So that one is queue. Sorry. FIFO is queue. The data type that allows FIFO, first in, first out, is queue. Where you go in, you come out the other side. The first that goes in is the first to come out the other side. That's another data type. But another data structure is called stack. This stack is the last to come in, will be the first to come out. It's just like you're stacking plates on top of each other. You want to start removing the first stack. Remember, you have to lift them up one by one. So it's stack. So it's called stack. A structure that keeps track of function calls. When a function is invoked, it's added to the stack. As you keep calling function, is being added to the stack. First, there is global scope. As you enter, that is the first one. As you are going, you call another function, call add number. As you add number, you call another function, call add it. So until the last one is done and moved out, the next one will not be done. You understand? The last to go out usually is the first to go in. You understand? So that's that. So call stack is stack that stores and executes active functions. So now let's talk about web APIs. Browser provide features like set timeout, fetch, document object models. These are web APIs. All these calls that are browser provided. Set timeouts. Remember, I don't know whether if you use set timeout, fetch, all this. Those are called web APIs. They are provided by the browser, and they handle asynchronous operation outside the main thread. They handle what? Asynchronous operations outside the main thread. That means external features that handle asynchronous tasks. These are external stuff that handle asynchronous stuff. They don't work on the main thread. This is the trick. It's just like another thing that works. It's just like a dummy processor that is outside the main stack. They allow it just like a mini virtual processor that JavaScript created for managing all those. Exactly. Welcome, sir. These are external features that handle async tasks. Welcome, sir. So we have call queues, a waiting line that stores complete asynchronous tasks, ready to push back to call stack for execution. So these are like queues. A queue for tasks waiting to be executed. Then we have event loops. How JavaScript executes code quickly. So let's break down on how JavaScript usually executes code. When you call a function, it pushes to the call stack, right? Whenever you call a function, it pushes it to the word call stack. And when the function is finished, it's popped off the stack, like we have said. It was LIFO, last in, first out. LIFO, LIFO, last in. When you call a function, automatically it's pushed into the call stack. You call it like all your functions that you define, and immediately you call them. As it's reading line by line, it sees a place that a function is called, it takes that process and pushes it to the call stack. Inside that function, now it starts reading that function, it pauses the other one that is going on. In fact, it pauses the other process and make sure it executes that function first. Inside that function, if there is another function that is called, it pauses the main function and starts focusing and call and carry the inner one and push it into the call stack again. You understand? Let's continue one by one. We'll get them. That's the mechanism we want to just review now. So first, whenever a function is called, it's automatically pushed into the call stack. And the last to be pushed into the call stack word is the first to move out. So if we don't finish that last one, we will not continue anything. That last one, we must finish it and pop it off the stack before we can continue whatever we are doing. So for example, you create a function called hello world or say hello, which actually logs out hello. And immediately you call it, it's going to be pushed into the call stack. So execution process, hey hellos is added to the call stack. Then console.log, which is another function, is runs because you are calling it again. It's still added to the call. If it did not run, say hello will not continue until console.log completes running. You understand? Okay. So whenever you call a function, like as you are calling it like this function is defined here, right? Calling it, it carries this process and puts it inside the call stack. Simple as that. And this says hello has another function called within it called console.log. Remember, console.log is a function that accepts what as a parameter, a string. It accepts this string called hello as a parameter to it. Log is pushed to another. Yeah, the function is called log. The main function is say hello, which immediately as it's been called, it's put to the call stack and the process starts running. It's running, it sees another function called console.log being called. Immediately push that process to the call stack again. Now there are two processes on the call stack. The first one which entered was say hello. Second one which follow is what? Console.log. So it starts dealing with the console.log, which is the last in. So until console.log finish, say hello will not run, will not complete. Yes. Yes. The call stack is just like a virtual memory inside your system. It's a virtual memory inside your system entirely. You understand, right? So the call stack is just like, let's just have it as an imaginary box. It's how they created it. It's just so it's an imaginary box stacked. You can stack processes on top. So say hello was called and it's pushed to that imaginary box. Immediately console.log is added, which is the last thing. Console.log completes execution. Then say hello completes execution. Then the stack is empty. You understand? So the function is removed from the stack. Immediately call stack. Immediately it's run. Key point: only one function runs at a time in a call stack. You don't run two processes at a stack. Remember, our objective is to quickly examine how JavaScript handle concurrency. You are doing this at the same time. You understand? I wait using asynchronous. Those are modern ways. We could just jump all this and start using it. It's what we are expected to do. But let's roll this thing quickly and go. So web API like set timeout. When you call asynchronous functions like set timeout, they handled over the web API environment, not immediately. They don't run immediately. They are handled somewhere else. They handle in web API environment. It is not on the call stack. So whenever you do this, set timeout, it should happen after. Remember this function, we call this function, right? What we call this function, it's pushed to the call stack. Then we call this function again. push to the call stack. So this is there first, followed by this. So what's happening internally? Set timeout goes into the web API, which is this. This goes into the web API, not to the call stack. The timer runs out outside the main thread. After 2 seconds, the callback console.log has moved to the task queue. So this thing package this and send it from the stack. We said there are things that are asynchronous, things that have to pause every other thing, like web APIs. If you call this quickly, let's create a file called java. Everybody, let's create a file. I think we understand this. There are two things we've talked about. One is what web environment, web API environment. Talked about the call stack. That all those web APIs like set timeouts, they are pushed to the web API to allow the call stack. So it's managing that timer until that time 200 seconds reach, then it pushes it back to the call stack. So those web API set timer. Which other one again? That we used to use set limit. There are those ones that we used to set. We will come there. So let's create a file called app.js, app.js, and we have, let's set timeout. There is set interval. So set timeout takes in two parameters. Number one is a function, right? Number one is a function, then number two, like we call it, number one is a function, then which is this, then number two is the time. So it's called a callback. A function passed into another function is called a callback. A function in JavaScript, a function passed into another function as a parameter is called what? A callback. A function passed into another function is called what? Please, let's memorize that. A function passed into another function is called what? So this function we're going to create is sort of anonymous. You know arrow function now. It's going to return console.log, which is just say hello after 3 seconds. Then what is the other parameter it passing? The other parameter it passes in is time, which is in milliseconds, right? So set timeout accepts two parameters. Number one is a callback, which is a function. Then number two is the milli time. What we are saying is immediately you call this is going to be pushed into the call stack. Let's do something. Let's log before the web API call, log after the web API call. And let's right click here and open an integrated terminal and run with node app.js. We say before the web API call, after the web API call, set timeout. What did you just see? What you just see is that we have said clearly that the last in is what? The first out. This went in first, right? Into the call stack, and it was executed. That was not depth. There was nothing holding it, especially. Then it was executed and taken off the call stack immediately. This was called. Instead of it to pause, because this is not concurrent, after this is the next. This was supposed to happen, but this is going to happen in 300 seconds. On a norms, it's supposed to pause this whole process first and allow this 300 milliseconds to happen before. But you notice, after this was sent before this came in. So this is the mechanism between the two. There are two interfaces we've talked about: the web API environment and the stack, called stack. I think this is the time we need a small, sorry, this is this is small. It's very, oh, guys, we have 4 people now. Watch. So, so the call stack is tricky. What can I use to demonstrate it? I think there is a new file dot draw IO. Good, nice. I have this. So I have this new. Let's add a new rectangle. There are 2 things we've talked about. This is the call stack, right? Then another thing is the web API environment. This is going to handle only web APIs like set timeout and all those asynchronous services. So this one awaits when the process is run, then it pushes. This is the call stack. The call stack does not run concurrently. It's only run one thing at a time. This is, and it runs it last in, first out. So this process was called first. Let's give it our. So this process was called. After that, Control D, does it work? Another process is called. After that, another process is called. Then this one now is a web API call. Control D. This is, let's say this one is a web API call, which is like all your set timeout and the synchronous services. It does not stay here. It's going to be moved into this web API environment, where it awaits its total execution first, while the other process continues. So this tag, after this one is done, it's popped off. After this one is done, it's popped off. This one now, oh, this is complete too. This one that we have scheduled for tasks, those synchronous, it's pushed back into the call stack, and immediately after that, it's executed and done. Then this continues. So that's the concurrency issue. That's what happened between asynchronous and non-asynchronous call. This is how JavaScript handles what. This is a virtual memory. This is another virtual memory. These are not 2 threads. This is just like a virtual memory that actually watch and wait for an asynchronous or things that takes time to complete the task first before pushing it back to the call stack. This is where the whole execution task happens. Are we clear with that? Let's not overflog it. In the case you want to overstudy it again, you can read that book, this book I did. You can still go through it. So that's how it all happens. Let's go back. Hope it's understandable, right? At least to the we said that JavaScript is single-threaded. How does it handle concurrent processes like asynchronous calls? Well, how it handles it is anything that looks like a synchronous call that needs another processor, another thread. Let's push it into the web API environment, where it is watched for completion. Immediately the process is completed, we push it back to the call stack. The call stack manages every single execution line by line. You understand? So all asynchronous or things that used to waste time are pushed from the call stack to the web API environment. Clear? Please, let's continue. So what happens is set timeout goes to the web API environment. The timer runs outside the main thread. Then after 2 seconds, the callback, which is this, moves back to the task queue. You understand? So callback queue. After web API finish their task, they send the callback function into the callback queue, waiting to be executed. However, they don't execute immediately. They wait for the call stack to be empty. You understand? So callback queue, after web API finish their task, they send the callback function into the callback queue, waiting to be executed. However, they don't execute what immediately. They wait till the stack is empty. So let's quickly do something. If the task is not empty, this will not come in. So let's console.log like 4 processes. process 1. So process 2, process 3, process 4 and 5 down to 7 until this stack is empty. Yes or not? So let's run. Well, this usually happens until the task is what? Empty. Hope it's clear. So that trick, I think we met this trick, Ebuka, while we are doing while loop, one period like that, and we say while x is less than or equal to 10. I want you to see this. Let x equal to 0. While x is less than, let's not console.log. Let's just put it inside while loop. I want it to inside the set timeout. That is at every 1 second it should log. What do you expect this code to run? What do you think would be the output of this code? Oh, sorry, no, this is 1 second. This set timeout takes into parameter a function which will be call a callback, and a millisecond, which it will run after every millisecond.
After 1 second, you get to pay.
Abi, that is the process, right? What do you think will be the output? That is what will happen now. This is a trick of the call stack, and that is why it is important for you to understand it. And this is the tricky question about JavaScript. On the norms, you are expecting this to write one after every 1 second. It should write 1, 2, 3, but it doesn't work like that. We said that set timeout will be pushed, will leave this place entirely, and this process will run first. Before that 1 second safe, this loop has been done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. While this thing is still at what? At the web API environment, waiting for each 1 second to happen first. When it come back, it returned, and x is now 11, no, because the while loop have completed. Do you understand what we're saying? Quickly, we go back to this draw.io. Every web API calls, will be pushed into the, let me add the text. How there is to add text in this thing safe? Is it T? I don't know. No, this is not Figma. This is one text. So I'm going to call this web API environment. So this place is just like outside the word stack, outside entirely, and this is the call stack. So the web API we called in this function. Where is it? The web API we call in this function. Where is the web API? The thing that used to take time here is the set timeout, right? It is pushed into the web API environment. That is that set timeout. Let's call this. Okay. The first thing, let's start by Control D. There are two major processes there. Number one is a loop, right? that was called. This loop was called immediately. This is a process that was called. Inside that process, so the first thing that was called was a while loop. A while loop that was first called. Then followed by, remember how it works. Within it, another was called, which is the set timeout, which is a web API, right? The next thing that was called was this, which is a set interval, set timeout, Abby? Timeout. Is it set timeout? Set timeout that was called, which is a web API, like we said. All web APIs, all those things that used to take time are pushed to the web API environment, and this process continues. So the while loop, forget about this one, and that process and this process continue. You know, after this, all this whole thing is pushed to somewhere else, and this while loop, x plus plus, while loop, x plus plus, while loop, x plus plus, so it reach 11 and it tapes out. When this thing came back after 1 second from the web API environment, this x has become 11. So when it was after 1 second, it came here already, and x is already what? So this is what is happening. X is already 11. This has already executed and left the stacks. In fact, this has been popped off. The while loop has been popped off at this time. Because there is nothing here anymore, it has been pushed to another. Look at how it was. After the while loop, a set timeout was called. A set timeout was something that took time. It was taken to the web API environment. Then the while loop called 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The process is done and it's popped out of the stack immediately. As it's popped out, after 1 second, this is done. It brought it back to the core stack. Is that clear? It might not be clear now. Long term to be clear. I see the faces are all getting dull already. But this is the whole technical things that happen during the process. This is the thing that makes JavaScript different from any other programming language. So the kind of questions that happen. So how they work together, Java core stack, web APIs, this handle only asynchronous call, event loop, task queue, so explanation. So that's about that. So I created a note, all these notes about concurrency, and it's nice for us to understand callback, event loops, and more, and dive deep. I'll send it in the case you want to take a personal dive. Now let's go back to our major objective, which is for Express, backend, creating server-side development. Our course, full is called MERN, MongoDB, Express, React, and what? Node.js. Node.js, all of them is built on that Node.js. How Node.js was done was, JavaScript was initially for the browser. It was only a scripting language for browsers to run. And it's run automatically by this Chromium engine. And there are other people that actually created, apart from Chromium engine, there are other engines that run JavaScript. But Chromium engine became very popular and fast. We call it Chromium V8, I don't know. Then later they know that JavaScript is very nice. Some experimental guy like that went and add some features to make it run. That thing that used to stay on Chrome or browsers that used to read JavaScript code and turns it to ones and zeros that computer can understand. It took that engine, combined it with some language, and add it so that thing can also be running on the server, on the back end, on your machine, every machine at home. That was how they did Java. So you can install that experiment called Node. That was when Node.js came. That means JavaScript can now run on your machine. Are you sleeping? Yeah, cold. Should I up this? Okay. All right. So I'm going to send this note later. We are not continuing that because I see the class is already getting boring. Let's get to the introduction. We are going to do two things. We are going to create a React.js app and combine some things together, at least on the basic. But first, let's get back to Node.js. By the end of this class, we will be able to understand what a server is and how it works with Node.js, and create a simple HTTP server that sends JavaScript object notation responses, which is how normal API works server side. Then handle different routes using conditional logics. We have talked about, I don't know whether we have, yes. We're talking about, is in this class we're talking about switch cases. That we have different types of conditional select, conditional statements. We have if and else, right? We use if and else, and we can use switch cases. And we say we use switch cases for discrete elements, things that does not concern range. One thing having one specific values. One thing, that's where we use switch cases very well. And we said that, I don't know whether it's this class, and say we use it very extensively in routes. Can use conditional logic, either switch case or if statement, but the best to use is always switch cases. Then we'll learn why we need express.js is used and how to improve Node.js normal. Node.js is just for server, but Express was built on Node.js for what? Server-side development. Without it, Node.js was already server-side development, but it has a lot of workaround, making it a little bit complex. Later they brought Express to make it more simpler, right? So this module will understand what a server is. Keyword we'll be using server. Server is